So I want to go through some practice problems of writing recursive and explicit functions for linear equations, for exponential equations, and for quadratic equations. So I have one example of each here. I thought it might be helpful for you guys to have something you could go home and reference. So the first thing you want to do is you want to look and see if you can identify what kind of function we're looking at. So this one right here, it's going down 9, down 7, down 5. So to me, that's pretty quickly indicating that I'm going to have a quadratic. So just continuing to be sure. Down 1, up 1. Yep, okay. And then I'm going to look at the second difference, which is a constant plus 2. So to me, that second difference being a constant number and the first difference being a linear equation tells me I'm looking at quadratic. So we're going to be doing a quadratic equation there. Let's come down and just look at what kind this is. So when I'm first looking at this, it doesn't look like there's going to be some kind of additive pattern, but I can say for sure that each number is 3 times the previous. So that multiplicative growth there is indicative of exponential functions. And the computer's kind of laggy here on some of these videos, but that's all right, we'll still get through it. Here, going down 2, down 2, down 2, and it looks like that pattern is continuous, so to me, this is definitely looking like a linear equation because of that constant first difference, and then when I'm comparing this to this, it definitely looks like I have a slope here. So I'm going up 1 here and down 2 on this side. So we're going to go ahead and start writing our equations down here at the bottom. So let's do a recursive one first. So to get to the next number from the current number, I'm adding 2. Okay. I could also say that my current number is my last number plus 2. So I just need to quantify which one I want to choose. I'm going to go ahead and choose to do it in this format. So my current a of n, if this is n, or you might call this a of x if we're talking about x, or f of x if we're talking about x. So my current y, a of n, is found by taking my last y, a of n minus 1, and adding 2 to it. And then I'm going to give somebody kind of a starting place, so I'm going to just choose a term here, and I'm going to say that where a of 0 is 5. So that's my recursive equation for a linear function, and they're all going to follow this same kind of pattern. Let's do an explicit. So there's a couple of different ways you could do it. You could do y equals mx plus b, or you could do y equals y sub 1 plus m times x minus x sub 1. A lot of you guys forgot to make that minus x sub 1 when you did the quiz. So come back over here, I'm looking at my table. The change in y over the change in x gives me a slope of 2 for all of my questions. So I could say y equals 2x plus my y-intercept, which is when x equals 0, 5. If I didn't happen to have that number in my table, I could build back to it if I wanted to, or I could plug in an xy as xy, that should be negative 2, as x and y, and solve for that b term. Either is fine. The other thing I can do is I can choose a point other than my one I used to find my slope. I can use any one on here, plug it in for these numbers, and then still use that. So y equals, I'm going to choose 2, 1, as my option. No particular reason, I just chose that one. Somebody else might have chose this one, or this one, or this one, or this one, or this one. It doesn't make a difference. So the y was 1. My slope is -2. And then I'm going to say x minus, and my x was +2, so -2. So this equation or this equation would work fine. But there's one thing that I noticed when I was looking at your guys' tests. It looked like you guys just kind of made equations and then you forgot to check and see if they work. So I'm going to do a check right here. So I'm going to use this point right here, one that I didn't use to build it. And I'm going to say is 3 equal to -2 times 1 plus 5. Well, this just becomes -2, and 5 minus 2 is 3, so yes, it works. So always check and make sure your equation works. You'll find a lot of mistakes that way. Okay, let's look here at exponential. So recursive functions. I'm going to do current equals my last, and then I have to figure out how to get from current to last. So my current a of n is my last a of n minus 1, and when I look at my table it looks like I'm multiplying by 3 to get up my y column. So I'm just multiplying by 3. And then I'm going to tell them that a of 0 is 1. And that's just coming from the table. Any point would be fine, but make sure that you choose one. I could have also maybe said that a of 1 is 3. That would be fine too, but you have to give somebody some piece of information so that they could recreate your table. Explicit functions for exponential equations is I like to start with my y-intercept here. And what I'm doing is I'm taking this number right here, 1. I'm taking that number and I'm multiplying it by 3 once, or I'm multiplying it by 3 twice. Or if this were 3, then I would have multiplied by 3, 1, 2, 3 times. So I'm taking my y-intercept and I'm multiplying by this number my x number of times. Okay. And then again, you always want to check your work. A lot of you guys just kind of, you put like +1 or something like that on your equations, and if you had tested it, you would have figured out that it didn't work. So I'm going to plug in, let's plug in 2. 9 here. So 9 equals 1 times 3 to the second, and 3 to the second is 9. So I get 1 times 9, and yes, 9 equals 9. So yes, it works. Okay, quadratics are the hardest. Let's start with the explicit one. And we're going to work backwards, and then we'll do the recursive one. So the explicit one, we have lots of different strategies we can use to write an explicit function. We can kind of just problem solve it out, looking for a pattern. Or if you happen to see a key feature and you know the equation that highlights that key feature, then you can just go to that function. So when I'm looking at this table here, I see it going down, 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 and then it kind of seems to scope, it has like a minimum down here at the bottom, and then it starts to go back up. That means that I have a vertex right here. So if I see a vertex, I should use vertex form. Okay. So y equals a times x minus h squared plus k. So y equals a times x minus the x value of the vertex squared minus 4. And then I need to calculate my a. see if it's not 1 or if it's something else. So I'm going to choose a point other than the one I used to build my vertex to solve for a. I'm going to use 0 because that makes my life easy. So 0 equals a times 0 minus 2 squared minus 4. So I'm going to add my 4 over to the other side. 0 minus 2 is negative 2, and negative 2 squared is positive 4. So that means that a must be 1. So that's easy. So y equals 1 times x minus 2 squared minus 4. Do I have to write that 1? No, but if it helps you to understand that a is 1, then you can write that. Recursive, a little bit more difficult than the previous ones. Recursive functions for quadratics are a little bit different because the change isn't the same from step to step. When we did exponential, it was always multiplying by the same number, or linear, we were subtracting or adding the same number. But here, we're adding a linear equation to get from one term to the next term. So our current term is our last term plus some linear equation, always. So current is a of n, and last is still a of n minus 1, but now I need to find out what this linear is. Well, this linear function is going to be built using this term and how I got to that term. So like this term and how I got to that term, or this term and how I got to that term. Okay? This number out here, just like it was in the bottom of the table, that constant change is our slope. That's the slope of our equation. So we're going to have 2 times the n, or x. We could do a of x and x minus 1, and that would be x there. And then I just have to figure out what my y-intercept is. So I could just test it if I wanted to. Negative 1 times 2 gives me negative 2. And then what would I have to add to negative 2 to get to negative 7? Well, it would have to be negative 5. So I'm going to make a prediction that my b is negative 5. And then I don't want to just hope that that's right. I want to check it. So let's check. Let's check with 2, negative 4. So I'm hoping that negative 4 is negative 3 plus this linear function. So I would have had to have taken 2 and multiplied it by my input 2. So this 2 is from this one, and this 2 is from here. And then subtracting 5. And so that gave me here, this all simplifies to negative 1. So is negative 4 equal to negative 3 minus 1? Check. So it works. So that's always a good thing. We always want to check and make sure it works. So there is our function for recursive, our function for explicit, for quadratic functions. Sometimes the vertex won't be on there, and I could make another video and send it to you guys on how to do some of those ones where it's not there. I hope this helps you get through the practice.